And our next speaker, Dénes Tóth, is actually building on Henrik's work, so it ties in quite nicely. So I'll hand over to him. Thank you.
Thank you very much, and thank you for coming, and also, of course, for the organizers to give me the chance to present this talk today. I'm Dénes Tóth, and I would like to present our radii.defer package, which is co-authored by Balázs, who is actually sitting there. And this package can be used for deferred execution of nested functions. I will tell you a bit about the context, why we needed this package. So we learned from Henrik that if you parallelize something, then you can make things faster. But actually, the fastest that you can do if you don't do this. So if you don't need to do it, then this is the fastest and most resource efficient way of doing something. So we are involved in a so-called pro-learning project, which is led by Professor Peter Cartons, the founder of Radii, which stands for Research Australia Development and Innovation Institute. And Peter has a dream that actually schools in Australia have lots of data everywhere, but they don't use it. We can even extend it by custom service, etc., with other sources. And this data could be processed automatically, and school teachers, school principals could ask questions, and the computer could respond them in a meaningful way to improve the progress of the students. And this is okay, it doesn't matter. So the last part is actually this education analytics, which we work on. So we use attendance behavior, external test data, and try to process them. So the challenges, even with the modest set of analytic procedures, so like density plots and correlation plots, etc., the number of potential analysis setups is extremely high due to potential filtering and subgrouping. So just an example for a question: how girls belonging to the 2014 entry cohort progressed in the numeracy NAPLAN domain. NAPLAN is a test in Australia. And also our target users do not have any data analytic or statistical skills. So what is the best way to guide the user to formulate meaningful questions that you can respond to? And what we found, especially at the start, we wanted to use Microsoft Always Encrypted. I don't know whether you heard about it. It is a client-side encryption procedure, so that actually all of your data goes encrypted to the database. So this makes it very secure. Unfortunately, when you look at the marketing, then you see that the overhead is about 10 to 20%. Okay, we measured 3,000 to 6,000 percent of bottleneck, so that we found the gathering the data was extremely slow. And also the data coverage, the missingness is also pretty large. And we know that the expected usage pattern is infrequent data uploads, so maximum 3 to 4 times per year. And the analytic questions will be highly overlapping, so that our users will be interested in very similar questions. So this is a lesson that we learned, that think first, code second. And by the way, of course, the former is much harder. So after many trials, we came up with this infrastructure. I don't know whether you can see anything of it. So actually, we use Shiny, and we use Shiny Proxy for this. We added a custom module which enables us to process HTTP-only cookies. So this is for the authentication part. And then the Shiny Proxy launches Docker containers. And inside the Docker container, we have the Shiny application which communicates with an Azure SQL database service. Just a quick demo. What we have here. Can you see anything of this? Or not really? So, oh yeah. Okay, the point is that actually we added now tons of custom JavaScripts to do nice things. So if I add new analysis, for example, I can select it from a gallery. Let's say this is, for example, a cohort progress plot. I add it to the panel. Then it gets there, or I can start a new analysis from scratch. And here the point is that we go through a series of questions. That is, okay, what is the level of the analysis? Let's say I want to analyze student groups. Okay, do you want to do comparison, or are you interested in distribution? What data you want to analyze? Let's say test, let's say NAPLAN. And then you can select the year level of the student, the calendar years that you are interested in, and the domains that you are interested in. No, I don't want to specify further subgrouping variables like gender or language at birth other than English group. And when we get here, then the calculation starts. We just create plot, but you can change the layout of the plot. Let's say we want to do the faceting by calendar year and multiple pages where each domain gets his own page or its own page. And then I click on finish. Then we get this style here. And we can even go further and change the plots. So this is actually a quite heavily customized Shiny application. Okay, and now in the background actually we use the radii.defer package all the time. I will present you an example. Oh, I forgot to start the timer. How many minutes do I? All right. Okay. So we load some libraries. Actually, we use the radii cache package, which is used for the caching, and it is defer object aware. Therefore, we needed a separate package and don't use the some other one. We will load also the future package, the ggplot, just for doing some plots, and the fortunes package. Of course, this is just for the example. And as a first step, I just create a cache. So here, actually, this is just a create cache command here. And then we have a cache object. And we also make it sure for this demo that we clear that we have an empty cache. So we do not cheat here. And we choose a multiprocess plan from the future package. Okay. So actually what we need in our application, we want to gather data, then we want to pass the data to the statistic function for processing, for calculation, and then we want to pass the results and maybe also the individual data to a plotting function. So this is the general schema. And now we will do something similar. So I just take a random quote from the fortunes package. Do you know the fortunes package? Who knows the fortunes package? Okay, the others who don't, just really load it and have fun reading the funny quotes coming from the R-Help mailing lists. And so here I define a function which has exactly one argument, which is delay. How many seconds we wait before doing the particular thing. And also our statistical function will be the calculation of frequency of letters. And then we will create a plot. And I don't show you here the code which does those things. The point is only here that we delay or function just for demoing that we do something slow here. Okay. So then how you can define a differ object? Shall I? Can you see anything from, or is it? So can you read it now? That here we create a differ object. We enter the function, and we pass the cache object as well. As you can see from the timing, it is almost instantaneous. So we haven't evaluated anything. We just described that we will want to execute that function sometime in the future. We also define a deferred object for the calculation. So we just pass the function, which will be this calc statistics. We pass as an X argument the data deferred object. It is not evaluated at all. We just signal that, okay, this will be our X argument, the evaluated return value of that deferred object, and the cache. And we do the very same for the plotting function, which has now two arguments, the data and the statistics. So nothing is evaluated at that point. If you run it for the first time, so with plot the result, actually it starts the evaluation of the plotting function. It realizes that, okay, we have an unevaluated argument in that function, which is the data. So it starts evaluating the data. Here you can see that data processing starts in 5 seconds. Then comes the statistical result, the frequency of letters. As you can remember, that function had one argument, that the data deferred object. This is not re-executed again, because now it is in the cache, because we just ran the data, we evaluated the data deferred object. So then we go on with calculating, so we're processing the calculation, and then the generation of the plot. So in total, we used 12 seconds for this, because there was no cache available. Okay, let's say this is the quote. If you can do without a makefile, that comes from Dirk. If you can do without a makefile, do without a makefile. That was in a discussion about the benefits of not changing the compiler in our packages. And this is the frequency of letters in that particular sentence. Okay, just imagine that we are in a shiny context. The user clicks on a control widget, so you have to change the parameter of your function. What you do here, for example, I update the statistic, the calculation differ object, that the delay now should be 2 seconds instead of the default 4. Okay, I updated this one. But you don't want to do anything actually with your statistics, because you want to update your plot. So you don't need to bother with this. You just call again the plot D result, and it will realize that its argument was updated, so it has to re-evaluate again that deferred object, and you know that only the calculation. So here you can see that the calculation starts in 2 seconds. Nothing is about data, because the X argument hasn't changed at all. So it is not even loaded. Maybe it is not even loaded from the cache. So if we realize that an underlying function, a deeply nested object, hasn't changed at all, that we can even skip the evaluation of it and use only the parent or the higher level function. Okay, and of course, that was we just changed the delay. It has nothing to do with the quote itself. So, of course, the resulting plot is the very same in that case. What if we want to perform this asynchronously? Then you can define a future differ object. So the plot or plot function will be now not only deferred, but it will be a future. So it will exploit the great functionalities of the future package. Actually, the API is the very same. You just simply tell that this should be a future differ object instead of a simple differ object. And when you execute this, you see I code another function from the differ package. Instead of asking for the result, I just told here that I want to execute that function. At that point, the future package in the background starts the execution. But of course, you get back almost instantaneously because we just created the future itself, so it is now non-blocking. We can do other things in the meantime. For example, we can ask whether that future is resolved or not. First, it is not resolved, of course. Then we wait for 4.5 seconds because we set the delay parameter to 4 seconds. In the meantime, this plotting function has been evaluated. So we can, I forgot to show you the result here. Of course, it would be, again, the very same plot. And you can also define a map differ object. Maybe you realized here and here. I will toggle to full screen. Here we have a particular calendar year where we have data, but the sample size was too low, so therefore statistics couldn't be calculated. So for example, you can split your task. This is the standard map reduce strategy. Split, apply, and then combine. Here, this will be a very simple function that we just get the quote with a delay of 1, 2, or 100, 200, or 300 milliseconds, and the author. And then we pass this map differ objects to another defer object, which will simply receive these two lists, unlist them, and paste them together. In our use case, of course, we use it with the data, so that we split our queries to small sets of data, then we do the calculations on these small data sets, and then we join them together to create the plot. Here what you can see, the data processing starts when it evaluates the first map differ object. Then, of course, it restarts again with a second, and then we get here the result. So nothing exceeds like Excel. That was quoted from Roger Conker, for example. Or firstly, don't call your matrix matrix. Would you call your dog dog? So as a summary, and actually a radii differ object is just a bad simple RSEX class where you define the function to be called and its arguments, and optionally the caching scheme and the arguments to be passed to future. You can nest arbitrary differ objects at arbitrary levels, so you can have 10 levels in your hierarchy if you wish. And when you ask the differs are evaluated in a top-down manner. And once the defer is executed, it is re-executed only if its arguments have been updated, and a deferred is not executed at all if the return value of its parent is known. So, and of course it can be used as a promise in asynchronous code. And I also would like to ask for an excuse. This is lesson 2. Try to be open source right from the start. We just realized that this is, of course, in private repos, this code that we use internally, and we thought that it would be easy to make the public version of it. But then we realized that we have to make some important design decisions before doing this step, because we don't want to get all of the dependencies that we use in the whole project, so we would like to get rid of them. So once that will be ready, the radii cache and radii defer packages will be available on GitHub. And thank you for your attention, and happy coding.
Okay, I think I'm afraid we've sort of run into the coffee break a bit, so we'll have a break, but if anybody has questions for Dénes, please come up to the front so it's easy to catch him. Thanks. And please thank our speaker.